So we've noticed so far that the examples, example A and B are just like grade 10. We solve by factoring. The factoring is really quick. We get our answers. In C, we had to do our new method of factoring because it's a cubic, and we had to go through all that process. But in the end, it still gave us a bunch of factors of which we could quickly see the answer. So we hope that that process is going to be true in D. So you've had a chance to try this on your own, or you might be trying it on your own. We're going to go off and see how it goes. So of course we have to guess some numbers, either 1, positive 1, negative 1, positive 3, or negative 3, and for no apparent reason I'm just going to guess 3. So I'm going to go 3 cubed minus 4 times 3 squared plus 2 times 3 plus 3. 27 minus 27. Is that right? No. 3 squared is 9 plus 4 is 36. So minus 36 plus 6 plus 3, and that equals 0. So shockingly, I guessed right on the very first time that 3 worked. So that means x minus 3 is a factor. So off to the side here, I'm going to divide my polynomial by x minus 3. So it's 1, negative 4, 2, and 3. And the thing I'm going to put is 3. So I do it with my synthetic division. So the 1 there, 1 times 3, add them as negative 1 and negative 3, add as negative 1 and negative 3, and 0. And so I've gone from here. I know that x minus 3 is a factor, and when I do my division, I realize that what I have left over is x squared minus x minus 1, and the whole thing is equal to 0. So we look at this and we're like, okay, so far so good. Now we need to look at what's left over and see if this can break down any further, because there are obviously some more answers here. So we go off and hopefully it's a nice one that we can factor. What two numbers multiply to negative 1 and add to negative 1? Yeah, nothing. So if this was a question from a couple of days ago where it just said factor, you have factored it and you're done. But we're not. We need to solve. So what do I need to do to solve this part? Sorry, what are we going to do? Yes, we have to go that step further and use the quadratic formula. So, unfortunately, the trinomial that we were left with wasn't factorable, but we can still go off and get an answer. So we're going to have to do that. So the quadratic formula here, we all know the song. We know, remember this, it's minus b plus or minus the square root of b squared minus 4ac all over 2a. I'll give you a moment to try this on your own. If you need to pause the video, you can. But be very careful and you carefully go off and do that. So you're trying it on your own. I'll go ahead and start solving. Luckily, all the numbers are 1, so the math shouldn't be too hard. Minus minus 1 is a plus 1, plus or minus 1 minus 4. Oh, sorry. I forgot the minus right here. So careful, I forgot the minus right there, so make sure you edit that if you're watching the video. So that makes this a plus 1, or plus 4, excuse me, over 2. And we end up with 1 plus or minus 5 over 2. How many answers do I have here? I got 2 there. for a total of 3. Don't forget, and this is where it's very easy to forget because you're spending all this time on the quadratic formula, that you already have one of the answers, right? This one, you have an answer of 3. And so we finally have a solution set of 3, 1 plus root 5 over 2, and 1 minus root 5 over 2. I think it's important when you go off and actually write the solution set, do write all 3 of them down. So write the plus answer for one and the minus answer for the other. It's a good way to remind yourself that there are 3 answers. Technically, you wouldn't be wrong if you put the plus or minus right here in the solution set. That'd be fine and correct. But you might get misled and think that there is only 2 answers when in fact there are 3. Okay? And this is the stage where why I taught you about the complex number system, because we know at sometimes when we do this we end up with a negative underneath the root sign, and that would lead to your complex roots. But for our purposes, we're probably only going to see questions that have real roots. They're just not nice ones. Okay? Don't go to your calculator here and tell me a decimal answer. That's not what I want. I want an exact answer. So leave it as a plus root 5 over 2 and a minus root 5 over 2. If it does work out nicely, like if this ends up being like right here, if this ends up being a 16, you take the square of that, you get a nice number. Well, if this ends up being a 16, you probably could have factored it in the first place. Okay? But sometimes you don't notice it and you go, oh, here it is. In that case, yeah, go off and actually give me the correct answer.